right? So now here this region of the curve, right? In this region of the curve, the voltage gain is almost constant, right? And this is called as this region where the voltage gain is almost constant is called as mid frequency region. Mid frequency region, right? Now this frequency, it is denoted as FL, and the voltage gain at frequency FL is AV by root 2, right? Or 0.707 of AV, right? And here also at this side of the curve, when the voltage gain is equal to 0.707 AV, that frequency is denoted by FH. Okay. So here this frequency region is called as low frequency region. Low frequency region. And here this region is called as high frequency region. Right? So this is a frequency graph of an amplifier. So if we see the frequency graph of an amplifier, then you start from zero frequency, right? If you are increasing this frequency, then there is increment in the voltage gain. At one particular frequency, FL, the voltage gain is equal to 0.707 of maximum voltage gain, right? And this frequency is denoted as FL. And this region of the graph is called as low frequency region. So your amplifier, if you are operating in this region, then it is a low frequency region. And after certain frequency of FL, the voltage gain will almost constant if you are increasing the frequency. But again, at higher frequency, the voltage gain starts decreasing, right? The voltage gain starts decreasing. Then a frequency will come that frequency denotes we denote as FH. At that frequency, again the voltage gain value will be equal to 0.707 of maximum voltage gain, right? So here this voltage gain here is generally denoted in dB, right? It is denoted in decibel, in dB. Why we denote this in dB? Because to our ears, we can recognize the change in the dB easily as compared to the general value of the voltage gain. That's why it is denoted in dB, right? Now here, generally if we are operating our amplifier, then what is our aim? Our aim is uh, it should give a constant voltage gain. It should give a constant voltage gain even if the frequency is changing, right? This is our main aim, because see, suppose this is one amplifier, right? This is one amplifier, and here means one transistor is there, and here we have connected some voltage source which has to be amplified, right? This is some voltage source which has to be amplified, and here we are taking the output. Here we are taking the output. So voltage gain is V out by V in. So this frequency of the signal which we want to amplify, it is a sinusoidal type of signal, right? Whose frequency is varying, right? Some this type of signal we are applying, right, for the amplification. So there is change in the frequency of this signal. So if we change, if the frequency of the signal is changing and the voltage gain is also changed due to change in frequency, then the analysis part of this amplifier will be different, right? Because at different frequency we are having some different voltage gain, at some different frequency we are having some different voltage gain, right? Because if we are changing the frequency and frequency due to the and this frequency affects the voltage gain of amplifier, then we find that the analysis part is different. At different frequencies we have to measure the voltage gain which is having some different values. So analysis part is difficult. So but if we see the voltage gain versus frequency graph, then we find that in some range of the frequencies, that is a mid frequency region, in that region the voltage gain is almost constant with the variation in the frequency, but in the other region you see that there is a change in the voltage gain if we are changing the frequency. Okay, now in low frequency region, low frequency region, you see here the voltage gain, peak voltage gain is AV, right? But in the low frequency region you find that there is the dip in the voltage gain, there is a decrement in the voltage gain. So which causes this decrement in the voltage gain? Yeah, can any student suggest why this voltage gain decreased in the low frequency region? Yeah, Any student? Okay, I will tell you. So in the low frequency region, you see this low frequency region. In this frequency region, the voltage gain is decreasing, right? If we move from FL towards 0, then we find that the voltage gain is decreasing. So which parameter of the transistor causes the decrement in the voltage gain? So in the low frequency region, we already studied that when we connect an amplifier, with the amplifier we have to connect the coupling capacitors, right? Yeah, unmute yourself. Okay. Unmute yourself. Who is this boy? Student. Coupling capacitors. And you also remember there is one bypass capacitor which is connected to RE. Bypass. So these two, coupling capacitors and bypass capacitors, are responsible for dip in AB. Okay. How they are responsible, that we will discuss, but you just understand in the low region the dip in the voltage gain is caused due to the coupling capacitors and bypass capacitor. And in high frequency region, high frequency region. So now again you see in the high frequency region, there also you find the dip in the voltage gain. So this dip in the voltage gain in the high frequency region is caused due to the internal capacitance of transistor. Transistor are responsible, right? Are responsible for dip in voltage gain, right? So right now you don't know what is the internal capacitances of the transistor. So we will discuss that also, right? But one thing you remember always, in the low frequency region, the dip in the voltage gain is due to the coupling capacitors and bypass capacitors. And in the high frequency region, the dip is due to the internal capacitance of the transistor. Now here FL, right? This is called as lower 3 dB frequency, and FH is higher 3 dB frequency, right? Now mid frequency region is suitable to operate the transistor for the amplification, right? So this point we should remember, mid frequency region. Region is suitable to operate transistor for amplification. Why? Yes, can anyone tell why mid frequency region is suitable for operate transistor for amplification?
The voltage gain is constant.
Yes. One minute, I'm coming. Okay, so mid frequency is suitable for operate transistor for amplification because ideally the frequency response of amplifier, ideally it should be flat over the entire range of frequency of the operation for the amplifier, right? And if it is changing, then there is a problem in the analysis part, right? So that's why. Now you see this FL frequency. This frequency is approximately. It is approximately uh, around 15 hertz, right? And higher frequency FH, its value is approximately 17 kilohertz. It is approximately 17 kilohertz, right? Okay. So now here bandwidth. There is a term bandwidth. Right. So this bandwidth is the range of the frequency over which we use a transistor is the bandwidth. So what is the range of the frequency over which we shall use the transistor? It is, if you see this figure, what is the range of the frequency? So see, if there is a dip in the voltage gain and the dip of the voltage gain is equal to 0.707 AV, up to here we can operate, right? Suppose the voltage gain is AV and the voltage gain due to the increment of the frequency or the decrement of the frequency, it reaches to 0.707 AV. Up to that frequency we can operate the transistor, right? So the bandwidth, if you see, FL is the frequency at which the AV is, voltage gain is 0.707 AV. Same way, FH is the frequency at the higher side where the voltage gain is 0.707 AV. So this range we can operate our transistor, and this range is called as bandwidth, right? So what is the frequency for the bandwidth? It is FH, right? If you start from here, this FH minus FL, FH minus FL, then this will be your bandwidth, right? So it is FH minus FL. Okay. Now here you can see, since FH greater than FL, right? Because see, FL is 15 hertz and FH is 17,000 hertz, right? So FH is very much higher than FL. So you can neglect this FL. Therefore, sometimes you can write the bandwidth is approximately equal to the value of FH. Bandwidth is approximately equal to the value of FH, right? Because if you in FH, if you subtract this 15, then 17,000 minus 15 will be how much? This is 17,000 minus 15. If you write, then it will be 16,985. It comes like so. It is approximately equal to your this 17,000, right? That's why bandwidth sometimes is also written as FH. Okay, right. Okay, students, today I have meeting right now, so I am stopping here. At 9:45 I have the meeting. Keep this. Okay.